Students, in this video we will learn how to find the value of a determinant using cofactors. So here we have to use using cofactors of elements of second row, evaluate the value of the determinant. So we have to find the value of the determinant using the cofactors of elements of the second row. So what is the second row? 6, 0, 4. So first of all we'll find out the position of the first element of second row, that is A21. So here let us solve this one. Solution. Here A21, that is the first element of row 2. So A21 is equal to 6. A21 equal to 6. Now what we have to do is next find the cofactor of A21. So therefore capital A21 denotes the cofactor of the element A21. So how we can obtain it? Minus 1 raised to the sum of 2 and 1, that is 2 plus 1, and then we'll get the determinant. What is the determinant? Cancel out all the elements in which the number 6 lies, the row and the column. 604, this is the here 6 lies in row 2, so cancel out all the elements of row 2 and all the elements of column 1. Remaining whatever elements are there, you make a determinant of that. So remaining, if you cancel it out, you will get 604 will be cancelled out. 261 is also being cancelled out. Remaining will be minus 3, 5 and minus 7. So we'll make a determinant of that. So this is minus 3, this is 5 and minus 7. So we'll solve this one. Equal to minus 1, 2 plus 1, that is 3 is odd, so this will remain minus 1. And solving this one, minus 3 into minus 7, that is 21, and 5 into 5, 25. So 21 minus 25. Remember that this is not mod. Equal to minus 1, 21 minus 25 is minus 4. So together it will be getting 4. So what is the value of A21? 4. Similarly, we will find A22 and capital A22. Then we will find A23 and cofactor of A23. So here A22 equal to A22 is 0 and capital A22. Actually there is no need to find capital A22 because we have to multiply A22 with capital A22. Since A22 is 0, so whatever value of A22 will be there, that is the cofactor of A22 will be there. The answer will be 0 only on multiplying. But still let us find it out. So where is A22? This is A22. Cancel out all the elements of that row and the column in which A00 0 lies. That is A22 lies. So cancel out this. That is column 2 and row 2. So remaining will be 2, 5, 1, 7. So minus 1 every time you write minus 1 and raise to the sum of these this I and j position, that is 2 plus 2 and the determinant. So what is the determinant? As I told you, cancel out all the elements in which the number 0 lies of the rows and columns. So 2, 5 and 1 minus 7. 2, 5, 1 minus 7. So minus 1 raised to 2 plus 2. 2 plus 2 is 4 and 4 is an even number, so this will become 1, positive 1, equal to 2 into minus 7, that is minus 14, and minus 5 is 1. So together we will be getting minus 17. Now similarly we'll find for the third element of second row, A23. What is A23? A23 equal to 4 and capital A23, that means the cofactor of A23 equal to, here cancel out all the elements of the rows and column in which 4, that is the element A23 lies. So cancelling out this one, row 2 and column 3, what we get? 2 minus 3, 1, 5. So that determinant will take minus 1 every time you have to write, raised to the power of sum of these two, 2 plus 3, and the determinant. Again, what is the determinant? Cancelling out this elements of row 2 and column 3. 2 minus 3, 1, 5. 2 minus 3, 1 and 5. So equal to minus 1 raised to 2 plus 3 is 5. 5 is an odd number, so it will become minus 1. Now let us simplify this. 5 to 10. Minus 3 into 1, minus 3. So we have to subtract it. So 10 minus minus 3, that is 10 plus 3. So together we will get minus 13. So this is minus 13. Now we will find the value of the determinant. So how we can find the value of the determinant? Therefore, delta equal to A21 multiply A21 with its cofactor A21 plus similarly second element of row 2 is A22 multiply with its cofactor plus third element of row 2 is A23 multiply with its cofactor. So this will give us the value of the determinant. Now let us put the values. A21, what is A21? 6. So we'll write here 6 into, what is the cofactor of 6? That is 4. So 6 into 4 plus A22 is 0 into A22 is 0 and its cofactor is minus 17. That is minus 17. This is why I told you, even if you do not find the cofactor of A22, then also you will get the answer, but this may not be true every time. So plus, now next one, A23. What is A23? A23 is 4 and multiply by the cofactor of 4. So what is the cofactor of 4? That is minus 13. So it is minus 13. Now let us solve this one further. 6 into 4, 24. Then we are having 4 into minus 13, that is 24 minus 52. So 24 minus 52 will give us, so this will give us minus 28. Therefore, the value of the determinant is minus 28. So how we have got? We have multiplied the elements of row 2 with the cofactors of that particular element and then added them. Then the value is, we are getting the value of the determinant. This way we can find the same concept we can use to find the value of the determinant along R1 or R3 or column 1, column 2, column 3. But take care, in board exams it is given R2 second row, you have to use only second row. If you use any other, then definitely it will be correct, but no marks will be allotted to you. Students, here we have question number 2 now. Using cofactors of elements of third column, evaluate delta equal to 1 x yz, 1 y zx, 1 z xy. Now we have to expand it along third column, but it do not mean that we cannot use properties. So first of all, we'll use properties, because if we bring zeros, then the calculation becomes far more easier. So always you must try to bring 2 or more zeros. So you can see on your own that if you subtract from R2 R1, this will become 0, and from R3 if you subtract R1, we will get 0. So let us apply this. Applying R2 becomes R2 minus R1 and R3 becomes R3 minus R1. We have, so here we are having delta equal to, row 1 is as it is, 1 x and yz. Now row 2, 1 minus 1, that will be 0. Then we have R2 minus R1, so y minus x, and zx minus yz, zx minus yz. So this is row 2. Similarly, from row 3 we subtract R1, 1 minus 1 is 0, z minus x, and xy minus yz. Now we are having, you can see here, let us solve it further. Delta equal to 1 x y z. Then 0, this we can write as, from here I can take out minus common, so it will become x minus y. From these two, x z, zx and yz, what is common? Z. We can take it common. We will get z x minus y. Now next, third row. Third row, this 0. Here also I will take minus common. I will get x minus z. And from xy minus yz, what is common? Y. So take out y common. So you will get x minus z. Now you can see that from row 2, 0 can be done as x minus 0 into x minus y. Similarly here we can write it as 0 into x minus z. So from R2 we can take out x minus y common, and from R3 we can take out x minus z common. So therefore, taking x minus y common from R2, x minus z common from R3, we have delta equal to 1 x yz. 1 x yz. Here 0 minus 1 and z. 0 minus 1 and y. And what has come out? X minus y and x minus z. Now from R2 we shift R3, then we will get one more zeros. We can expand here also, but if you bring more zeros, this is better. So let us apply that. Applying R3 becomes, or R3 or R2, we can do any. So let us do R2. Applying R2 becomes R2 minus R3. We have, even we can do for R3 also. Right now I am doing for R2. So we have delta equal to, there is no change in R1, so it will remain as it is, 1 x and yz. Then R2 minus R3, 0 minus 0, minus 1 plus 1, this will become 0, and this will become z minus y. So 0 minus 1 y. Here we are having x minus y, x minus z. So this is what we have got here. Now what we can do, from row 2 we can take out z minus y common, or we can take out y minus z common. Any we can take out common. So let us take out z minus y common from R2. So next step, taking z minus y common from R2, we have taking z minus y common from R2, taking z minus y common from R2, this is R2, we have, so what we are having, delta equal to, here already we have x minus y, x minus z out of the determinant. So x minus y into x minus y into x minus z. So x minus z multiplied by z minus y. And now remaining determinant will be, this one, 1 x yz. First row is 1 x yz. 1 x, this is yz. Then R2 will be here 0, 0 and 1. 0, 0 and 1. 1, why? Because we have taken z minus y common. And now third row is 0 minus 1 y. 0 minus 1 y. Now we'll expand along column, see here, expanding along column 3, third column. So we'll expand along column 3. Expanding along expanding along column 3, expanding along C3, we have, so expanding along column 3 we have delta equal to x minus y, x minus z, z minus y. Now I am expanding along column 3 into, so 1 into, sorry, along column 3, so yz. So first element is yz, then cancel out all the elements in the row and the column in which yz lies. So yz, if you cancel it out, remaining will be 0, minus 1, and so the determinant is 0, 0, 0, minus 1, and then we'll take the second element plus minus 1. Why minus 1? Because the position of this is, or what is the position of this element? It is A13. This is A21, A22, A23, this is A23, and this is A33. So A23, if you add 2 and 3, we will get 5. So minus 1 raised to 5. You know how to find the cofactor. So therefore this will become minus 1, and minus 1 cancel out all the elements in which the element 1 lies. So all the elements of the rows and the columns. So this is row 2 and column 3. So remaining will be 1x and 0, minus 1, then plus y, third element is y of column number 3, and cancelling all the other elements of the row and the column in which it lies. So remaining will be 1x and 0 and 0. So now we'll simplify it further. So delta equal to x minus y, x minus z, z minus y. Now this will become y into z. This is 0. Yz into 0, total is 0. Then minus 1, minus plus minus 1 into is minus 1, and that is remaining is 0. So into minus 1, and plus what we'll get it here is plus y into 1 into 0 is 0, x into 0, so y into 0. So this is what we'll get. So therefore delta equal to x minus y, x minus z, and z minus y, because total will be 1 only. So this is our solution. Now here, if you want, we can also write this one as delta equal to x minus y. This can be written as y minus z and z minus x. So from here, taking minus common, minus 1, and also minus 1 common from here. So minus 1 into minus 1 is plus 1. But both are correct. You can write either this one or this one. Both are correct. There is no need to write 1 here. So that will be your answer. Either you write x minus y, y minus z, z minus x, or x minus y, x minus z, z minus y. All are correct. So this is our solution.